Hello everyone, today we're going to be working on fundamental problem 6-1, and this problem is asking us to determine the force in each member of the truss and to also state if the members are in tension or in compression. So the first thing that we're going to do is we're going to determine how many reactions there are in this truss and then find the values for them and then proceed to finding the forces of the members. So taking a look at this figure, we have for point A, we have what looks to be as a roller. So we know that a roller will have that vertical reaction. I'm going to assume that the vertical reaction is going to be going upwards. And we're going to call this A of Y. Now for point C, we have a pin support, meaning that there's going to be a vertical reaction and a horizontal reaction. I'm going to assume here that our vertical reaction will be going downwards. We're going to call it C of Y. And then for our horizontal reaction, I'm going to assume that it's going to be going to the right. We're going to call this C of X. So now we're going to determine the value of those reactions. And to do that, I'm just going to be taking the sum of the forces in the X and the Y direction and also taking the sum of a moment about a point. So to start off, I'm going to be looking at this figure, I'm going to be taking the sum of the forces in the X direction, because here we have the 600 pounds going to the left, and our other horizontal force is the C of X. So anything going to the right is positive. We know that the sum of our forces in the X direction have to equal 0. And like how we saw earlier, the 600 pounds are going to the left, so that's a negative force, negative 600 pounds. And I assume that our C of X is going to the right, so that would be a positive force, positive C of X is equal to 0. We solve for C of X. We end up getting that C of X is 600 pounds. We got a positive number, meaning that we assumed correctly, so we know that this C of X is going to be going to the right. So I'm just going to go up here, and now I'm going to replace C of X with the force, 600 pounds. Now, since I have two unknown vertical forces, if I take the sum of the forces in the y direction, I'm not going to be able to do much with it. So what I'm going to do is I'm going to take the sum of a moment about a point, either about point A or C, so that way I could determine the value of the other one. I'm going to be taking the sum of the moment about point A. That way I could determine the value for C of Y. So counterclockwise, positive, the sum of the moment about point A have to equal 0. So from there we have our 600 pounds up here. Remember, moment is equal to the force times the distance. So our force is of 600 pounds, and our distance is going to be 4 feet. As you can see, this bar right here has a length of 4 feet. And since it's acting to the left, we know that's going to be creating that counterclockwise moment, meaning positive moment. So positive moment of the force times the distance. From there, we have our C of Y. We assume that our C of Y is going to be acting downwards. So that means it's going to be creating that clockwise moment, meaning negative moment. From there, our force is what we're trying to determine, and our distance is going to be the span of this whole bar, which is 4 feet plus 4 feet, so 8 feet. So negative moment of the force times the distance. And From there, we know that our C of X will not be creating a moment since it lies right there. So it's not going to be creating a moment. So that's all the forces that are going to be creating a moment. From here, we could just solve for C of Y. So we end up getting 2,400 pound-feet minus 8CY is equal to 0. So we end up solving for CY. We end up getting that C of Y is equal to 300 pounds. We ended up getting a positive number, meaning that we assumed correctly. So we know that C of Y will be acting downwards. That reaction is going to be going downwards. So now that we found the value of C of Y, we can now proceed to doing the sum of the forces in the Y direction to determine the value for A of Y. Upwards positive. We know that the sum of our forces in our Y direction have to equal 0. So for here, we assume that A sub Y is going to be going upwards, and then our other vertical reaction is just our C of Y. We found that it has a value of 800 pounds going downwards, so that means negative force. So A sub Y minus 800 pounds has to equal 0. We end up getting that A sub Y is equal to 800 pounds. We got a positive number, meaning we assumed correctly. So we do know that that reaction will be going upwards. So now that we found the values of all of our reactions, the next thing that we're going to do is now we're going to be able to proceed to finding the forces of each of those members of the truss. Sorry, 300 pounds. 300? Yes. I don't know why I wrote 800. So sorry. I'm sorry, you guys. I think I read the 3 as a 8. But yes, 300 pounds. There we go. Yes, that makes much more sense. Okay. So now to determine the forces of each of those members, what I'm gonna be using is the method of joints to determine the forces and determining whether they are in tension or in compression. So I'm just gonna take a quick look at this and I'm gonna see which joint I could start off with and possibly determining more than one member at a time. So I'm taking a look at this and I'm going to start off with joint C. And that way I'd be able to determine the force of bar AB and, BC and bar CD. So the second part would be using method of joints. The first joint that I'm going to be drawing out is joint C. So if we were to draw joint C, that would be our joint C. We have our C of X, our reaction C of X, with a value of 600 pounds. Then we have our C of Y with a value of 300 pounds. From there, we have our two bars, B, C, and CD. I'm going to assume that the bars are in tension for right now. So I'm going to be drawing them outwards. So this is bar BC. So I'm going to be calling this force BC. And then from there, we have our bar CD, which is a little bit slanted. I'm going to draw it a different color real quick. And this is bar CD, so I'm going to be calling this force CD. So if we go back to this figure, we know that the length of this bar is 4 feet long. The length of this bar is 4 feet long. So we know based off of that, we would use, sorry, if we were to determine the hypotenuse, we end up getting that this triangle is a 1 square root of 2 triangle. So we're going to use that to be able to determine the value of the forces. So we're going to quickly write that here. This it has a slope of 1 square root of 2. So now what I'm going to do is I'm going to take the sum of the forces in the x direction to be able to determine forces. So we have that going to the right is positive. The sum of our forces in the x direction have to equal 0. So from there, we have our force of BC, which we know that it is, well, I assume that it's in tension. So in this case, it's going to the left, so that's going to be negative. Actually, no. I'm going to take the sum of the forces in the y direction, because if I do the x direction, I'm going to have two unknowns. Yeah, sorry, you guys. We're going to take the sum of the forces in the y direction. So we have the only two vertical forces that we have is the 300 pounds, and we know that the force of the bar CD has a vertical component, so that's another one. So we have negative 300 pounds. And then from there, since we assume that this bar is in tension, we know that it's going to be going outwards from that joint, meaning that it's going upwards, so positive force. And so now to determine the vertical component of it, we're going to go back to our slope, and we're trying to determine the vertical component of it. That's why we're going to be multiplying that force of CD by 1, which is the rise part of our slope, over the square root of 2. So we have 1 over the square root of 2 times the force of CD. We know that this equals 0. From there, we solve for the force of CD. So we have 1 over the square root of 2 force of CD is equal to 300 pounds. If we solve for it, we end up getting that force. The force of the bar CD is equal to 424.3 pounds. We end up getting a positive number by assuming that it's in tension. So that means that it is in tension. If we would have gotten a negative number, that means that it would actually be in compression. So with that, we determined already one of the forces of the member of the truss. Now that I found the force of the bar CD, I'm going to proceed and using some of the forces in the x direction. So here we have that positive 600 pounds, negative the force of BC, and since we know that it is in tension, we know that it's going upwards and slanted to the left, so another negative force. So we have positive 600 pounds minus the force of BC minus, so now we're trying to determine the horizontal component of the force of the bar CD. So now I'm going to be multiplying it by 1 over the square root of 2. Now you may think that I'm using the same equation, but let's say, for example, if this side of the triangle had a value of 3 Then to determine the horizontal component of this force, I'd be multiplying it by 3 over the square root of 2. So yes, in this example, we do multiply it essentially by the same number, but that's because they both have the same value. But remember, when you're trying to determine the vertical component of it, you're going to be using that vertical side of the triangle, multiply it by the over the hypotenuse, horizontal component, that horizontal side of the triangle over the hypotenuse. So minus 1 over the square root over 2, and this time we do know the value of 4CD, so 424.3 pounds has to equal 0. If we solve for force BC, we end up getting that force BC is equal to 300 pounds. We end up getting a positive number, meaning that it is also in tension. Now I'm just going to be quickly going up here. Remember, it asked us to state if the members are in tension or in compression. So now what I'm going to go is I'm going to go up here. I'm just going to draw a little dash. And we know that the bar CD has a force of 424.3 pounds in tension. And for bar BC, we know that it has a force of 600 pounds in tension as well. So now that we found those two values, now I'm going to proceed and using the method of joints on point A. That way I could determine the force of AB and AD. So joint A, we were to draw out joint A, we'd have our reaction of 300 pounds going upwards. From there, I'm going to assume once again that the forces of the members are in tensions. So this is force AB. From there, we have once again a slanted member. This is going to be force AD. Going back to the figure, we know that this triangle is also has a length of 4 feet this way, 4 feet this way. So once again, we know that this is a 1 square root of 2 triangle. So I'm going to go ahead and write that out right here. 1 square root of 2. So now what I'm going to do is I'm going to take the sum of the moments in the sum of the forces in the y direction. Sum of the forces in the y direction have to equal 0. Here we have positive 300 pounds. And then from there, since we assume that the force of the bar AD is in tension, it's going upwards. So positive force. Here, we're trying to determine the vertical component of it. So we're going to be multiplying the force of AD by 1 over the square root of 2 times force AD is equal to 0. If we solve for force AD, we end up getting that force AD is equal to negative 424.3 pounds. Since we got a negative number, we know that that bar is going to be in compression. So now we're going to go ahead and take the sum of the forces in the x direction. So here we assume that force AB is in tension, so positive force AB. From there, since we had assumed that force AD is in tension, but sorry, my bad. So now that we know that that force, the force of the bar AD is in compression, we know that it's actually going to be looking like this. But either way, it doesn't matter because either way we have that the value, it has a value of negative 424.3 pounds. So either you could write the negative here or in the parentheses. So I'm just going to write it out like this. Plus, we're trying to find the horizontal component. So we're going to be multiplying the force AD by the horizontal component of the triangle over square root of 2. So 1 over the square root of 2 times the force of AD, we know that the force AD is equal to negative 424.3 pounds. We know that that has to equal 0. If we solve for force AB, we end up getting that it has a value of 300 pounds, positive number, so that means that it is in tension. So now I'm going to go up here and I'm going to state the forces that we found. We know that the force of the bar AB has a force of 300 pounds in tension. And then here for the bar AD, we know that it has a force of negative 424.3 pounds, meaning that it is in compression. Now I'm going to be using the method of joints on point B to determine the force of BD. So technically, by looking at this, we already know that it has a value of 0 because if you guys remember, there is a, I forgot what it's called, but basically like a property or something where if there is just one force right in the middle of these two forces and there's no other force. So there's like no other bar right here or another bar right here. And if you see that it is completely vertical in between two forces, we know that this is going to have a force of 0. But I'm gonna just show you guys if you guys would like to show, I guess, the work, the math for it. But you guys should be able to tell that in between two forces, and I guess you could call it, I like viewing it as like a windshield wiper in a way. So here we have our windshield. This is our windshield wiper. If it's vertical, completely vertical, not slanted, and also there is no other member. If it would have had one more member, then you can't use this rule, but only vertical member, no more forces to it, we know that that has a value of 0. And I'm going to show you guys why. So now we're going to do joint B real quick. Joint B, if we were to draw it out, we found out that the force of the bar BC is 600 pounds and it is in tension, so that means it is going away from that joint. We also found out that the force of the bar AB is also in tension, so away from that joint. A force of 300 pounds. And then we have our bar BD, which we're trying to determine the force. I'm going to assume tension, so going also away from the joint. This is force BD. So as you guys can see, if I were to take, since we know that this is completely vertical, so that just means that it just has a force in the y direction. If I were to take the sum of the forces in the y direction, this is the only force here. So force BD, there's no other force that has that vertical component to it. So we just end it with saying force BD is equal to 0. So that is your answer. This is how you could show it if you want to use math. behind it. But if not, you could quickly just glance at the figure and be like, oh, that has a force of 0. So once again, to what we did with this fundamental problem, we started off by determining how many reactions there are and the values of those reactions. And then from there, we use method of joints, going one by one to determining the forces of each of the members of the truss. Thank you guys so much for watching this video. If you guys like this video, please feel free to hit that thumbs up button and also feel free to subscribe to our channel if you guys would like to see more videos like this one.